So to start us off with, I have a 2.5 molar sodium hydroxide solution. I have a 1.5 molar H2SO4 sulfuric acid solution. That's a diprotic acid. Somebody poured some volume of acid into a beaker. We don't know how much, but we do know that it's going to take us 35 milliliters of the NaOH solution to perfectly react with it. So the question is, what was that volume? How much sulfuric acid solution did we use? So see if you can solve it. Give it a shot for a minute or two. Go ahead and pause this video and then come on back. Alright, so how are we going to solve this one? Well, I'm adding a volume of the sodium hydroxide. I know the volume and I know the molarity of the sodium hydroxide. Remember, all the concentration and volume does is tell us moles. And I'm doing a reaction. I need moles. And so the first step is to find moles of what I can, which is the NaOH. 35 milliliters. Well, there's 1,000 milliliters in 1 liter, so 0.035 liters of NaOH solution. So I know my volume in liters, because that's what molarity is in. And so 0.035 liters of the sodium hydroxide solution. And in every 1 liter of the solution, there is 2.5 moles of the chemical. And so we have our volume, we multiply it by our molarity, that gives us our moles. Because what will happen is our volumes will cancel out, we'll be left in moles. And so 0.035 times 2.5, we're going to find is 0.0875 mole of NaOH. So that's how much sodium hydroxide had to get used. That's how much was over in here. Well, how much acid did it react with? Remember, this is a diprotic acid. If we try to do the balanced reaction, NaOH plus H2SO4 is going to react, well, we're going to get rid of the hydrogens and replace them with sodiums. So Na2SO4 would be the deprotonated acid, so all the protons that can leave are gone. And then OH and the hydrogen will make water, but I've got 2 hydrogens, so I'm going to need 2 OHs in the end. I'm going to end up with 2 waters. So I needed 2 sodiums for the sulfates, I needed 2 sodium hydroxides. It's a 2 to 1. I need twice as much sodium hydroxide. So I know how many moles of hydroxide I have. I can use it to find moles of the H2SO4. 0.0875 mole NaOH. There are 2 mole NaOH in every 1 mole of the H2SO4. So divide that by 2. 0.04375 mole the H2SO4. So in whatever volume, back up here, we had, whatever volume of the sulfuric acid solution we had to obtain 0.04375 moles of it. Well, we knew the concentration. Back up at the start, it said it was 1.5 molar H2SO4. I know the moles I want. I know the concentration. And so I can set up a way to find volume. 0.04375 mole of H2SO4. There is 1.5 mole of H2SO4 in every 1 liter of the solution. So that divided by 1.5. So basically if you have your moles and you divide them by your molarity, you will get your volume. So in our case, this is 0.02912 liters of H2SO4 solution, which way back at the start we had 2 sig figs for our concentration, so 29 milliliters. The volume the original container must have had way back at the start must have been 29 milliliters of sulfuric acid solution. That would have required 35 mils of sodium hydroxide solution to complete the react. Well, let's do a slightly different one. In this one, I have a volume of HCl solution. So it's half molar. I have 1 container of hydrochloric acid solution. I have 25 mils of a 0.75 molar sodium hydroxide solution. I'm going to combine them, and I'm going to add some extra water. So there's 110 plus 25 plus whatever's necessary to bring it up to 200. The idea in this problem is we're not trying to find stoichiometric amounts. Right? We're given specific amounts of each. I have a volume and a molarity for both of them. And back last time we said if you have a volume times a molarity, that gives you moles. So for both chemicals, I actually have moles. This is the limiting reagent problem, basically. One of these won't be enough. One of them will be left over. I'm going to clue you in right now, it's the HCl. We'll have HCl left over. The idea is some of it will go away though, so how much will be left? Because our goal is to find the pH. Remember that our pH is dependent on the amount of H plus around, and if you have strong acid, that is your H plus amount. Whatever amount your strong acid gives you, that is your H plus amount. So as a result, we need to figure out how much strong acid is left so that we can solve the pH. And so for both of these, we need to calculate out those moles. And so let's do our HCl. So I have, 110 milliliters is 110 liters of the HCl solution. In 1 liter, there is 0.5 mole of HCl. And so we will find 0.11 times 0.5, 0.055 mole of HCl. In terms of the sodium hydroxide, we have 25 milliliters or 0.025 liters of NaOH solution. And the molarity for that is 0.75, so 0.75 mole in 1 liter. And so 0.025 times 0.75. And what we will find is that it is 0.01875. 0.01875 mole of NaOH. So I clearly have more HCl than sodium hydroxide. It's a monoprotic acid, so they're 1-to-1. So I can just subtract them. Remaining or leftover HCl is going to equal 0.055 minus 0.01875. So 0.03625 mole of HCl remain. Well, all of that is going to be in our final volume, which was 200 milliliters. So we can find our concentration. 0.03625 mole of HCl over 0.200 liters. So that divided by 0.2. 0.101 molar HCl. Since HCl is one of our strong acids, it breaks fully apart, so that is 0.101 molar H+. And if I want pH, it is the negative log of the H+ molarity, H+ concentration. So negative log of 0.101, let's see, that's negative log, our pH is equal to 0.7417, and, well, I think I left us with one sig fig in this problem. Let's pretend I gave you a little more sig fig. So, 0.7417 is our pH, or reasonably 0.7.